Welcome to Homework Lib.
This is chapter 35, problem number 52. We have a plot, delta y versus 1 over d, delta y being the separation between adjacent fringes in an interference pattern, 1 over d is being the inverse of the separation distance between the slits. And we have the plot, delta y versus 1 over d. Let's look at the equation that gives us the position of a bright fringe, y equals r m lambda over d for a single one. So if you're looking at the adjacent fringes, now delta y is going to be r delta m lambda over d. Delta m, if you're looking at the adjacent, delta m is always going to be equal to 0. So r lambda over d gives us the position, well, the separation between adjacent fringes. In this equation, this is also the answer to part A, obviously, this equation resembles a straight line because it's in the form of y equals m times x. This m here is the slope, okay? I mean slope here. So then our delta y is like the y function that we have. 1 over d is like our x. Let's write it here. X is 1 over d. Y is our delta y. Then the slope, which I called it an m, that equals to r times lambda. So yes, it resembles a straight line. Now in part B, we are actually asked to calculate lambda if using the information from the graph. Now, we're going to use the information regarding the slope. We said slope equals to r times lambda. Also, we know from the definition of the slope, how we can calculate the slope is that we can pick 2 points, let's call them delta y2, and then subtract delta y1 from the previous one. And then we can pick let's not call it delta. We can pick a point along x-axis that corresponds to this y, right? So then it's going to be 1 over d at the same point minus 1 over d at the point 1, but on the x-axis this time, right? So we can calculate the slope like this. After this point, it's up to you to pick what points you're going to choose. I'm going to pick 2 random points. I'm going to pick, let's write it in the x and y form. My x is going to be 10 millimeter inverse and then 5.5 millimeter. This is going to be my first point. And my second point in the xy form is going to be 0.5, 0.5 millimeter inverse and 0.5 millimeter. So having these 2 points, all we're going to do now is to subtract this from this, as you can see in the equation. So it's going to be 5.5 minus 0.5. Again, this is in millimeters, okay? Let's remember, divided by 10 millimeter inverse minus 0.5 millimeter inverse. Again, you don't have to pick these 2 points, but that's what I prefer to do. You can plot this in Excel and it would give you the slope. You can use that slope as your guide. Either way is fine. So from here, then your slope would be 0.526 millimeter squared. That, as you know, it has to be equal to r times lambda, and r was given to us as 0.9 meters. All we need to do now is to divide both sides by r. So then it's 0.526 millimeters squared divided by 0.9 millimeters. Now we need to do the conversion from millimeter squared to meter squared. 0.526 times 10 to the power of -6 meters, right? Because it's square, divided by 0.9 meters. So this will give us something like 584.44 nanometers for our wavelength.